Welcome to Ahiravata Motor and CV Motion Technology. Today we are going to take a look inside at how X1's binder jet 3D printing technology helps Ahiravata make its sustainable manufacturing vision a reality in serial production. The mechanical design of a vehicle engine head, commonly known as a cylinder head, is a complex process that involves a combination of material science, thermodynamics, fluid dynamics, and structural engineering. Here's a detailed overview of the key aspects and considerations involved in the mechanical design of an engine head. Detailed component breakdown: combustion chamber. The shape and size impact the compression ratio and efficiency. Intake and exhaust ports, designed to optimize airflow dynamics. Valves and seats, made from heat-resistant materials to withstand combustion temperatures. Spark plug/bore, positioned for optimal ignition timing and coverage in gasoline engines. Camshaft bearings, support the camshaft in OHC designs. Cooling passages, strategically located to manage heat dissipation. Oil passages, ensure lubrication of moving parts. Head gasket surface, precision machined for a perfect seal. Dash advances and innovations. Variable valve timing, VVT, mechanisms integrated into the head to improve efficiency and performance. Welcome to Ahiravata Motor and CV Motion Technology. Today we are going to take a look inside at KSB factory facility how X1's binder jet 3D printing technology helps Ahiravata make its sustainable manufacturing vision a reality in serial production. Inside the pioneering AM journey of Ahiravata and X1 cast components, producing cylinder heads and engine power case and head. KSB and X1 has been a digital manufacturing partner with Ahiravata Motor, helping to place a new production path for intelligent components. Today, Ahiravata uses 4 of our Axial 3D printing systems, our top-of-the-line model for processing. These digital manufacturing systems are highly efficient, producing more than 1,000 different core types a day. In the next month, 2 systems are slated to be added, expanding production to multiple 100,000 pieces throughout a year, and making Ahiravata a true pioneer in using additive manufacturing for sustainable serial production. The additive manufacturing technology at the core of this transformation is binder jetting. There are 2 main steps. A thin layer of sand is deposited in the job box. Next, an inkjet printhead spreads a binder to join the particles together where desired. This process is repeated layer by layer until the cores are complete. Importantly, Ahiravata and CV Motion Technology uses an inorganic binder in our printers. This sustainable binder chemistry does not emit odors or emissions during the metal casting process, which makes it more earth-friendly. What's more, the performance of these binders delivers the high accuracy and quality that Ahiravata Motor standards requires. And because it's 3D printing, we can deliver complex designs with ease. But what makes this binder jetting technology especially friendly to serial production is its extremely high speed. Ahiravata Motor relies on this technology for the final production of the 2- and 4-cylinder engines. After the sand cores are printed, they are mated with molds for pressure casting in the factory. A new technologies that lay the blueprint for a new manufacturing future. Together, Ahiravata Motor, KSB and X1 are demonstrating how binder jet 3D printing can be used for sustainable serial production with less waste, virtually no emissions. The process of ovening, or industrial baking, involves several stages, designed to ensure consistent quality, safety, and efficiency in the production of baked goods. Here's an overview of the typical steps involved in industrial ovening.